In this case, we are replacing a conductor-based changeover system to a motorized changeover system. The conductor base is old and worn out. Some contacts of the conductor cannot close properly, so leading to single facing on some circuits in the building. So we need to replace this changeover system so that we can have proper contacts closing at the same time to avoid the case of single facing. So first things first, we are starting today on site by preparing all the material we will use for the build. So on site today we have the motorized changeover system, the metal panel to house all the components, the timers, breakers, and a current control model. The bolts we're having for today are longer than we expected, so we're going to also trim them. We'll be using the back plate of the metal panel to mount all the devices on. So we definitely have to drill holes there as you're seeing, and we will also use it to mount the changeover system and a DIN rail that will host the other devices that we'll be needing for the day. Continue by configuring the stop and start module of the generator so that we can have an automatic mode and a manual mode. So to have the automatic mode functioning, this particular module of the generator, we have configured 2 signal cables or 2 sensing cables that are definitely close to start and open to stop. Some modules of the generator, we might introduce a stop and start module to it, especially generators that are older and does not have the capability of starting and stopping automatically. As well as if you have a generator which does not even have the capability at all, but has a stop and start key, then we can transform it to an automatic start and automatic stop generator. Then we configure it to be able to run with the changeover system. In this case today, though an older model of the generator, but it has that capability of starting and stopping automatically, so we only needed to configure it and look for the sensing cables that we'll use for the build. After configuration, we literally just draw our schematics based on the configurations we have made of the generator. As you can see on our rough sketches, we have the timing sequence for the automatic transfer from generator to mains, and from mains to generator. We draw the control circuit based on the automatic transfer switch we have. In this case, we have a motorized transfer switch, and we also just draw the power circuit. In this case, it's a 3-phase 4-wire system. After mounting every component, we wire the system, followed by proper testing. The key things we test are to make sure the system works as our timing sequence is drawn. The good thing about this automatic transfer switch is that the mains and generator can never meet accidentally, as it is already having a mechanical interlock feature built in. After building and installing, as you can see, the automatic transfer switch works well. In the absence of the mains, the generator kicks in and transfers in the timing sequence we have allocated. Thank you for watching. Subscribe, stay blessed, and stay connected.